Hey everyone, welcome to 5.2 Part 2. This is a follow-up to Part 1, obviously. I'm not really going to be doing any adding and subtracting examples, mostly focusing on multiplying and a little bit of dividing. We will get more intensive into dividing in 5.3. Okay, so the first thing I go over is the sum and difference, sorry, I read the wrong thing, the special product patterns. Now, there are a few out there. Common one is a sum and difference. I like to call it a difference of two squares because basically you're squaring the first thing and the second thing, and there'll be a minus in front, in between. So like this one, x plus 3 times x minus 3 just gets you x squared minus 9 because x squared is x. When you're squaring x, that's x squared. When you're squaring 3, that's 9, and then there's a minus in between. So that's why I'm calling it a difference of squares. Then you have the square of a binomial pattern, or have this a squared plus 2ab plus b squared. Unless there's a minus sign in the middle, you just have to look for how the minus signs change them. Like if you look at the cube of the binomial, if it's plus, it's obviously all plus. But if it's a minus in the middle, then you have a minus there at the beginning and the end. And then over here, I just put some common errors that people make when it says like do a plus b squared or a minus b squared. They just square each term, and that's not really what's going on. So the square of the binomial right here, see a plus b squared would equal this, something like this, and not that. Same thing for if it's cubed, it's going to look like something like that and not like that. That's what I'm trying to say. So I have these notes written ahead of time to save time, and because you could tell that some of it's written, a lot to write. So pause the video as often as you like. Make sure your audio's on, and let's get going. So this is a sum and difference problem. And so what did it mean by a and b? It doesn't matter the sign. A is going to be x, b is 7. See, if I had written minus 7 first, you'd be tempted to say b is negative 7. Just make b 7 and just follow the pattern, okay? You could do this by distributing. It would just take a little bit longer. But what's x squared? X squared. What's 7 squared? 49. Throw a minus sign in the middle. That's it. What about a square of a binomial? Well, it's going to follow this pattern. Because it's a minus sign in the middle, I have a minus 2ab. So a is x, so that's x squared. B is just a 4. See, so when it said 2ab, I plugged in a 4, just a 4. I didn't plug in a negative 4. The negative is being taken care of already by this formula, okay? And then when I'm squaring, negative 4 squared and 4 squared is the same thing, but I just wrote a 4 squared. So it says b squared, I wrote 4 squared. And then, so how did I get the minus 8x? Because that's negative 2x times 4, so that's negative 8. And throw an x there. So that's all there is to it for a square of a binomial one. If it's a cube of a binomial, well then this is the pattern that it will take. So my a is y, my b is 5, and so it says a to the third, so I wrote y to the third. Then it says 3a squared b, so a squared is y squared, b is just a 5, and I did 3 times 5, that's 15. So then I just had the y squared with it. Then it said 3ab squared. So 3a is y, b squared is 5 squared. So what's 5 squared equal? 25. What's 25 times 3? 75. So I got 75y right there. And b to the third is 5 to the third, and that's just 125. So you'll notice on these answers and the ones to come, that your answers, your powers, go down by 1. Power of 2, power of 1, power of 0. Power of 3, power of 2, power of 1, power of 0, okay? So that's the pattern you should be looking out for. If you miss something, you might have done it wrong, unless it was one of these sum and difference problems, in which case, you're only going to have 2 terms if you have the same thing, just a plus sign and then a minus sign, okay? Other than that, you're always going to have at least 3. So if it's to the power of 2, you'll have 3 terms, generally speaking. you'll have 2 or 3. If it's power of 3, you'll generally have 4 terms. If it's power of 4, you'll generally have 5 terms, and so on. So speaking of fourth power, this is Pascal's triangle, okay? And, well, this is Pascal's triangle. Pascal's an old mathematician and came up with this pattern of numbers that if you add the number to the outside, to the neck that's next to it, it'll start forming this triangle. So it's like, what's 1 plus, well, there's no numbers next to it. So like, what's 1 plus 0 and what's 0 plus 1? Imagine there being zeros there. You could also just tell yourself, just write ones for the walls of the triangle. But, so yeah, 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 2, and then 0 plus 1 is 1, 1 plus nothing is 1. Then I did 1 plus 2 is 3. Well, I didn't do it, he did it. 2 plus 1 is 3, and nothing plus 1 is 1, 1 plus nothing is 1, nothing plus 1 is 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 plus nothing is 1. You getting the picture now? So Pascal's triangle just pops up here and there for certain math things. It's kind of interesting how it gets applied. I know I've seen it like in, I want to say, statistics classes. And I want to say I've also seen it in a pre-cal class. But basically those numbers are going to be your coefficients to fit the patterns. So the one right next to it, the reason why it's circled a plus b to the fourth is because it's to the fourth power. So I wrote that over here in blue, and you see my coefficients 1, 4, 6, 4, 1, and then I wrote it again here 1, 4, 6, 4, 1, and then I plugged in everything for a and b. A is x, b is 3, so 1x to the fourth, this is my final answer right here in black, okay, so this is the final answer. I know it's a little weird because I have the formula, I have some work, then the formula, then the final answer. But so 1x to the fourth is x to the fourth. Then 4a third b. So a to the third is x to the third. B is just a 3. So what's 4 times 3? 12. 12x to the third. All right, so it says 6a squared b squared. A squared's x squared. B squared's 3 squared. 3 squared makes 9. What's 9 times 6? 54. Then it said 4ab to the third. So a is x, b to the third is 3 to the third. That makes 27. 27 times 4? 108. Then I have 1b to the fourth. So that's 1 times 3 to the fourth. That just makes 1 times 81. So that's 81. That's the final answer. So trust me, it's a lot quicker doing it like this than doing it the old-fashioned way. So what would it look like doing it the old-fashioned way? I just kind of stopped here, but if you did x to the fourth power, x plus 4 to the fourth power, then you'd have to write it all out 4 times, and then you'd start distributing. So x plus 4 times x plus 4 gets me x squared plus 4x plus 4x plus 64. Oh, 16. Oh, here I am messing up. And then you have to distribute everything to this. So x squared times x, 4x times x, 4x times x, 16 times x, and then everything times 4. And it just gets a little ridiculous. There's a lot to write down. So I didn't even really finish doing that because it's way quicker to do this. This scribbling down here is some notes I made during class. I think it was me showing what I wrote over here, but I think this is a little bit better representation. So just ignore that. Just pay attention to all this, okay? So, complex multiplying of polynomials. All right. I just complex because it was this just a little bit easier than doing this, a little bit less to write down. Let's get this out of here. All right, there. Okay, so just distribute x times x squared is x to the third. X times negative 12x is negative 12x squared. X times 35 is 35x. 2 times x squared is 2x squared. 2 times negative 12x is negative 24x. 2 times 35 is 70. So look, you have 2 terms here, 3 terms there. So you should have 2 times 3 is 6 terms. You should have 6 terms. 1, 2, 3, 4, 5, 6. But a couple things add. So that is negative 12x squared and 2x squared. Both have x squared, so they combine for negative 10x squared. And 35x and negative 24x both have x's, so that combines for 11x. But these on the outside don't have like terms, so they just wrote them down again. Okay, so yeah, let's go over the one right next to it. So similar process. I just distributed the x to everything to get 3x to the third, negative 2x squared, and positive 2x, okay? And then in red I did 5 times 3x squared is 15x squared, 5 times negative 2x is negative 10x, and 5 times 2 is 10. And so now let's just add like terms. Negative 2x squared, 15x squared is 13x squared. 2x, negative 10x is negative 8x. 3x to the third and 10 don't have like terms, so I wrote them there at the end. And that's all there is to say about that. So let's go on to the next section. Okay, so this section is dividing polynomials with remainders. So let me zoom back in. Well, what is a remainder? A remainder is, in part 1, we did some dividing with polynomials, but there was no remainder, okay? Like, there was, like, not the one, this part wasn't there. Because this divides normally. X to the third divided by x to the first is x squared. Negative 2x squared divided by x is negative 2x. 3x divided by x is just 3. But 1 doesn't have an x, so 1 over x can't simplify. So guess what? I wrote it as 1 over x. So that's what we call a remainder when it doesn't perfectly simplify. Okay? So let's look at this example right next to it. We have a remainder, but it did simplify a little, so let me talk a little bit about that. 4x squared divided by 2x is, well, 4 divided by 2 is 2, and x squared divided by x is x. 3x divided by 2x, the x's would cancel, so you just got 3 over 2, or 1.5. And then 8 over 2x, well, instead of writing 8 over 2x, because 8 doesn't have an x, so it's not like you'll just get something nice. 8 divided by 2 is 4 over 1. Instead of writing the 1 by the x, I just wrote 4 over x. So this is my remainder. I understand that it might be confusing because that's a fraction, but that perfectly divided 3x over 2x. The x is canceled. You know, if I wrote this out as 1.5, maybe it would look less confusing. But yeah, this is the remainder because it's dividing by something still. So yeah, I guess that's the way of putting it. But yeah, that's going to wrap it up for the notes. So stay tuned for part 3 where we get into some synthetic, for 5.3 where we get into some synthetic division and long division. Otherwise, thanks for watching. Bye.